Today's lesson is about de Moivre's theorem, and it involves taking a complex number and converting it to polar form and then raising it to a power. So before we get to de Moivre's theorem, we're going to talk about a few things with complex numbers, and one is how we graph them. So first of all, we are going to look at an axis here, and we're going to say that the x-axis is the real axis, and the y-axis is the imaginary axis. And we'll say that this corresponds to B, and the real axis corresponds with A. So if we take a complex number and we put it in rectangular form, we have z equals a plus bi, and we've worked with complex numbers before. A is the real and b is the imaginary, and we would plot them like a comma b. So if I pick a point in the first quadrant and I create a vector to that point, that would be graphing z. And the length, which is the absolute value z, and if we drop an altitude, that would be an A and a B, so we get a right triangle, and that's where it comes down in the next one when it says absolute value of a complex number and length. That's why we're going to basically do the Pythagorean theorem, and we'll show that to you in a minute. So if I'm going to plot these, then I'm going to draw a coordinate axis, and I am going to count off. So 1, 2, 3, 4, etc. My little spaces here, and we'll plot the first point. So I would plot -2, 3, put a dot, and then we draw, and the vector goes right to the point and no further. So that's z1. z2, -3, -3, draw. So it's basically point plotting as you know it, but complex numbers are expressed as vectors. So we'll do it like that, and that would be z3. Okay, so that shows you quite simply how to plot those. Okay, next item up for business. Now we're going to talk about what polar form of a complex number is. So the a plus bi is rectangular form, and this one comes with a shortened form where you can squeeze this down into r cis theta, and cis is cosine plus I sine. So in order to convert that, our steps are going to be a lot like what we use to convert points, but this time we're dealing with complex numbers. So what you're going to do, I'm going to move my box to the middle so that I can give you some instructions. The first thing you're going to do is graph the complex number, because we want our angle to be where our complex number is. And then we're going to find r and theta. And lastly, we're going to write it in the form r cis theta. So you have to keep the two separated, that the points are r comma theta, but the complex number has the cis in the middle. So if I graph this one, and it doesn't have to be a very specific thing, that would be a 1 and a negative square root of 3. And so if we think about that one, we might remember, but if not, here we go. So r is equal to the square root of 1 squared plus negative square root of 3 squared, and that's going to give us the square root of 4, which is a 2. And then for theta, we're going to use the inverse tangent, again like we did before, And the inverse tangent is going to be b over a. So negative square root of 3 over 1. And then we put that in our calculator, and we get negative 60. Now, negative 60, we want our angles between 0 and 360, so we have to go ahead and add 360 to that. So we're going to use the angle 300. So now, once we have those two things, we're going to say r, oops, let's try that again, r cis theta. So the r is 2, and then cis 300. And there is polar form of the complex number. So the good news is the math that's required isn't as bad, but we still have to go through and make sure that we're correct. Now here's one where when I'm going to draw my picture, so I go -3, 4, and when we do the Pythagorean theorem, we know that's going to be 5, but just in case we're not remembering well, so that's the square root of 25, or r is 5. Now when we go to find the angle, inverse tangent of 4 over -3. Now this one is not on the trig sheet, so when we go to the calculator to find our angle, we're going to get negative 53.1. Now we've got a couple problems. One, that's not between 0 and 360, and 2, it is not in quadrant number 2. So remember, a negative 53.1 is the reference angle. So if I came off my picture, my angle of rotation is negative 53.1, so that means my reference angle is 53.1. And then vertical angles, the angle that I would want to use to find that second quadrant, is 180 minus 53.1, and that is approximately 126.9. And so now we're ready to put it in the format that we want, which is r cis theta. And so my r, 5, cis 126.9. And there we go. So there's two good working examples for you there. Now, when I go from convert to rectangular form, the first thing that I am going to do is expand this into 3, and then I'm going to write cosine 40 plus I sine 40. And if they were on our trig sheet, we'd use exact values. So we're basically going to take 3 times the cosine of 40 plus 3 times the sine of 40, and then we're going to put the I after it. And so in your calculator, mode in degrees, there's our final answer. So rectangular form is A plus BI, and polar form is R cis theta. Okay, so the next thing we're going to do is talk about product and quotient. And here, the formula looks bad, but it's really not. At the top, it says R times S, two complex numbers in polar form. You're going to multiply the directed distance, which is R, and S, whatever they might be, and then you're going to add the angles, and then here you're going to divide the directed distance, and we're going to subtract the angles. And the thing that's common to both is angle between 0 and 360. So we want to make sure that that angle is in between 0 and 360 before we say we're finally done and the answer's good. So the first thing we're going to do with our little problem here is we're going to write these in shortened polar form. So this one's going to be 2 square root of 2 cis 135. And the other one is going to be Z2 is going to be 6 cis 300. And then what you're going to do, so the first part asks us for Z1 times Z2. Jeez. So we are going to multiply the two distances. So 2 square root of 2 times 6, and then cis, and then we're going to add 135 plus 300. So this is going to give us 12 square root of 2 cis 435. And then we realize that that's above 360, so 12 square root of 2 cis, and when I subtract 360, I get 75. That is the polar form of our answer. Okay, so really the formula, it looks like it's going to be bad, but it really isn't. Z1 divided by Z2, we're going to take the two directed distances and divide them. Write down cis, take the two angles and subtract them, and then simplify. Excuse me. And so that's going to give me square root of 2 over 3 cis negative 165. Again, remember, we have to make sure that's between 0 and 360. Excuse me. So we're going to add 360 to that one to make it comply. Okay, now finally, what the section is named for is de Moivre's theorem. So what it says is we're going to raise to a power, we're going to raise the directed distance to the power, and then we're going to multiply by the angle by that directed distance. Okay, so first things first. This one, this is in quadrant 1. So in order to do this, we have to convert to polar. So this is a 1, 1, and a square root of 2 triangle. So we have to convert to polar first. So the r is the square root of 2. We know the angle in there is 45. Inverse tangent, 1 over 1. So in the first quadrant, who's got a tangent of 1? The angle would be 45. So now this polar number is z equals square root of 2 cis 35. And now we're raising it to the third power. So z to the third square root of 2 cis, oh, not 35, nuts, cis 45. And we're going to raise that to the third power. So now, here comes de Moivre. Z cubed, square root of 2 raised to the third power, cis, take the power, multiply it by the angle. That's it. So square root of 2 times square root of 2 is a 2. So 2 square root of 2 cis. 3 times 145 is 135. That's between 0 and 360, and we're done. So the big deal here is convert to polar, because you can't apply de Moivre without polar form. Okay, next example. Okay, so we'll draw a picture. This one, 2, negative 1. So my r is the square root of 2 squared plus negative 1 squared. So r is the square root of 5. And now we're going to find the angle. So theta equals inverse tangent of negative 1 over 2. That's not going to be on our trig sheet, so we're going to use our calculator. Negative 26.6. That's a fourth quadrant angle, but it's not between 0 and 360. So we're going to add 360, and we're going to take 333.4 as our angle. So next move, z equals square root of 5 cis 333.4. And now it's up to us. We're going to raise that to the fourth power. So z to the fourth power, square root of 5 to the fourth power, cis 4, because that's the power, times the angle, 333.4. Z to the fourth, square root of 5 times square root of 5 is 5. 5 times 5, 25. Cis, I multiply that, I get 1333.6. That's well over the 0 to 360. So we are going to say 25 is good. We're going to keep subtracting 360 until we're within the bounds. And 253.6. So really just keeping in mind what you need to do and then watching for little details like angles between 360.